morning everyone. Welcome to the presentation of research method. My name is Lakhan Kotare. I'm doing my masters in mechanical engineering at University of Wollongong, and today I would like to speak about my research topic, that is improvement in high strength steel from cracking. So before knowing how it gets failure, we should know what is meant by high strength steel and how it is categorized and how it leads to the cracking. So first thing is that the microstructure alloy steel having the yield strain in between 350 to 700 megapascal are known as the high strength steel. Nowadays, due to increased use of high strength steel, it is the responsibility to make it more safer and reliable. Nowadays, the most important challenge is making the high strength steel crack free. So to measure the crack, there is a method, crack tip opening displacement, which measure the fracture toughness of the material and gives the property of a material which can resist the cracking. So CTOD, that is the crack tip opening displacement method, is conducted. So here you can see the experimental setup of the method. So any specimen and its properties can be measured. So just it is fixed into the jaws and heat is applied to the stress is applied to the specimen. So up to how much stress it can sustain and up to how much heat it can sustain before failure, so we can analyze from the experiment. And for our high strength steel, which factors are affecting to get it failure? So out of that, first one is the crack growth in high strength steel. So crack is the physical discontinuity in the transient heat thermal condition which leads to the cracking. So cracking, there are so many researchers did the study and they suggested that out of that, the first one is the Queen Bing in 2004. He studied and he said that if we change the external stress, the crack changes. Means if we put too much load on the structure, it gets to the cracking and it leads to the cracking. Even there's another scientist who studied and suggested by the Leon in 1996 that the crack resistance decreases with the increase in the specimen thickness. If we increase the thickness of the specimen, the crack resistance decreases also. And nowadays, the reliability decreases with the presence of crack. If there is a presence of crack in the high strength steel, no one gonna to use in the structure because of the presence of crack, which leads to the failure. The second thing which affect on the failure or which leads to the failure of the high strength steel is the welding method. While welding the high strength steel metals, we should take care of the weldment parameters and the heat input method. So here, because welding gives the strain to the material, which is most important in the structural design. Even if the proper care is not taken while welding, so it will make the structure failure, or it can make the material more ductile, which can lead to the failure. So we should choose carefully the weldments and the heat input method, because heat input method can affect on the microstructure and microstructure can affect on the failure again. So which are gonna to explain. Because in the welding method, pores are generated and which can make the material more ductile, so it can get easily failure or fracture. So what is the microstructural effect which leads to the cracking of the high strength steel again? So microstructure influence the properties of material. So if the microstructure is not proper, it can lead to the failure. Means while giving the heat treatment to the any specimen, if the heat input rate is not constant, it can lead to the generation of the pores, intergranular ferrite, and so many internal structures or grains which cannot be refined and make the structure failure more easily. So here, due to the microstructure, so the study done by the Anafolas SAM in in 2016, he suggested that there is a direct relation between microstructure and the fracture. So if your specimen has the proper microstructure, it cannot be get fractured easily. So here he suggested to select the best and safe material for the structural design. Even during the heat treatment process, if the bainite formation is there, it is more sensitive to the cracking. So we should take care of the microstructure of the specimen as well while choosing for the high strength steel. So the key point of my literature which leads to the research topic. So because of these three topics, 3 points, that is the crack generation, welding heat input method, or the welding of the high strength steel, and the third one is microstructure. So these 3 points leads the cracking of the high strength steel, which leads to the research to how we can avoid them to make it more safe. So what I did in my research, I did 2 experiments. First one, I choose the 30 centimeter of specimen of ENGG851 standard steel, and I did the first normalizing heat treatment process on it. So before heat treatment process, you can see the structure or the microstructure of the material, and after heat treatment you can see it gives the more toughness. So if you get the more toughness, we can resist to the cracking. So the second process or the experiment I have done on the same specimen of the normalized heat treatment process, the welding. So here I did 2 weldings with the different heat input methods, and from that here I just take care of the weldment parameter and the heat input method. So here you can easily see that the section 2 or the experiment number 2 gives the more toughness than the experiment 1 because of the heat input method and the welding parameter. So heat input method is most important in the welding or during welding of the high strength steel. Results. So from my experiment, what I have done is so it can reduce the welding heat input and the quality of the welded joints get improved. If we take care of the heat input method properly, it can improve the weld joints, and it can give the more strength, so it cannot be get fracture or the crack generation easily. Even due to the microstructural study, the refining it also refines the grain, and which makes the material more tough. Normalizing heat treatment gives that, as I said in the experiment, after the heat treatment process, it gives the more toughness to the material, and there is no bainite formation, means there is no brittle structure, means directly it leads to there is no fracture in our high strength steel, or there is no cracking. Importance of my research topic. So what I have done from that, the importance is we can just make our structure more safe and reliable and applicable for any use. Nowadays the large construction needs the proper welding method and proper heat input method as well. So from my experiment you can see that we have to take care of heat input method as well, and to enhance the design by lowering the weight of the structure and lowering the manufacturing cost as well. So these are the some importance of my research topic. Advantages of my research topic. So what are the advantages? It can suggest you to give the heat treatment process in the high strength steel. It can give you the proper welding method. It can give you the heat input method, and the generation of the crack can be reduced by giving the proper heat and by reducing the formation of bainite and intergranular ferrites. Disadvantages. Actually there are no disadvantages of my research, but there are some limitations, and those are: first, it is conducted in the room temperature. It is done on the 2 specimens only, and to get the accurate result we need to do it repeatedly. Thank you.